Lynette, in the interest of time, because I know you have biology at 3:20 with Mr. Bine. So in the interest of time, let me request you to, so that we can have an opening prayer as we wait for our friends. Lynette, Lynette,
Yes, yes.
can we have an opening prayer as we wait for our friends? Yes.
In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Amen.
Father, I want to thank you for this day. I want to thank you for protecting us during the night, Lord Father. Lord Father, and we thank you for the gift of our parents and teachers. As we are going to attend these remaining lessons of the afternoon, may we understand whatever the teacher is going to teach us, Lord Father. And may you provide us with the spirit of understanding, Lord Father. And chase away the spirit of dozing, the spirit of not understanding. Just now, I pray, amen.
Amen. In the name of the Father, the Son, and the Holy Spirit. Amen.
Amen.
Thank you very much, Lynette. Seeing other people are just coming in now. So I will not waste time, but I will go to the screen and I will show you what you looked at last time. Okay. So last time you looked at what we call logarithm, isn't it? We're looking at logarithm. Lynette, are you there?
Yes.
All right. So we're looking at logarithm, and Teacher Watimon told me that you people have done a logarithm, you have understood the logarithm, you know how to use log tables, you know how to find the logs of different numbers. And today we are going to look at the
That,
application of logarithm, the applications of logarithm. I hope you can see my screen.
now you.
You can see my screen very well. So today we are looking at the
Yes.
applications of logarithm. Cynthia, Cynthia, can you see the screen very well? Cynthia, are you there? Okay, I think Cynthia has just gone off. She's there, but I think she cannot hear me and she's muted. So, application of logarithm, that is our subtopic. All right, members, I'm going to be a bit slow, but a bit sure of what we are doing so that you understand very well. So logarithm can be used in multiplication and also in division of numbers. It can also be used in finding the square roots of numbers. So first of all, we are going to look at how to use logarithm so that we can multiply different numbers. So we shall find the product of different numbers. And we have already seen how to get logarithm of numbers. You have already studied how to get the anti-logarithm of different logs. So with those two things, we are going to base on those two things, finding the logarithm and also finding the anti-log. But you should also remember that for you to find the logarithm, you must apply what we call standardization. So you must standardize a number such that the number is expressed in the terms of 10 with a power on it. And then afterwards you proceed, you find its logarithm. Then after there, you can go ahead and find the antilog. So remember very well that when you're looking at indices, if I may try to write something here. So when we are looking at indices, you looked at, first of all, we are looking at multiplication. So part A, multiplication, using logarithm, logarithms. So remember very well that when we're looking at indices, we looked at some laws of indices, and we say that whenever we are multiplying numbers of the same base, if we are multiplying numbers of the same base, we add the powers. Are we together? We add the powers, and then when we are dividing numbers of the same base, we subtract the powers. So even here in logarithm, when we want to multiply two numbers but using logarithm, we shall add up the logs, or we shall add up the logarithm of those two numbers, and then the answer we get, we shall find the antilog of the answer, and should give us the final answer that we get when we multiply those two numbers. Okay, so now let us go back and see from our notes here. From our notes, so they are saying that we have this example which is here. It is saying that example 6. I want you to note down that example 6 is telling you that evaluate. So you write that question. It says evaluate. You write the question, evaluate 4.5 times 6.27 using logarithm. That's the question we are looking at. We are going to multiply 4.5 times 6.27 using logs, using logarithm, or using logs. So now what we should do is, number one, we should first find the logs of those two numbers. We first find the logs of those two numbers. So we are going to first find the logs of those two numbers. So this is what we are going to do, is that we find the log of 4.5, and also we shall find the log of 2.6. So when we use our log tables, we want to find the log of 4.5, and let us use the log tables here and look at logarithm. So 4.5, so we are here. So the log of 4.5, this is logarithm. So just know here there is a point 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, like that. So we have to look for 45, which is 4.5 here, and it is giving us 6.532. It is giving us 6.532 what? 32. Members, are we together? Members, are you there?
Yes.
Yeah, I don't want to teach myself. I want to hear people. So please unmute, members. Unmute. Class must be active. Class must be active. Unmute so that we can hear one another. Those ones who have just joined in, we are looking at logarithm, multiplication of logarithms. Multiplication of logarithms. We are multiplying, we are looking at this question. Evaluate 4.5 times 6.27. That is the first example. Evaluate that, and that's our first example. So we have to first get the log of 4.5. 4.5. We have to first get the log of 4.5. And for us to find the log of 4.5, we must use the log table. So we are going to go and look for 4.5 in our mathematical tables. So 4.5, if I may zoom in, 4.5 is here. So this is 45, but there is a point. This is 4.5, 4.6, 4.7, 4.8, 4.9. So 4.5 is here, and we have 6.532. So it means that there our answer is 0.0.0 0.6532. That is the log of 4.5. Okay, the next thing we get the log of 6.27. 6.27. So let us look for the log of 6.27. So we have to first look for 62, 62, and then we go to 7. So let us look for 62. Members, are you there?
Yes, we are there.
Okay, so this is 62, and 62 is giving me 62 is giving me 0.79. So I have 0. I can write it down. I have 0.7. That is 62, 0.7924. But because there is a 7 here, so I'll go to the column of 7. Are we together? I'll go to the column of 7, not of 0, but this is 62. So I'll go to the column of 7, and the column of 7 is here. So this is 7. I'm looking for 627, 627. So 627 is giving me 0.7973. I hope you can see this value here, 0.7973. Okay, so I can write that one down, and I say this is 0.7973. 7973. Okay. Right. So that is the log of 6.27. Now, we go back to our question. So you can see that's the log that they got. Now, when we are multiplying these two numbers of 4.5 times 6.27, we shall get, we shall say that we have 10 to the power of this log 0.6532, then times 10 to the power 0.7973. Then afterwards, what we are going to do is we are going to add those logs here. We are going to add the logs and then find the antilog. So we shall have 10 to the power. If you add that without looking at the notes, if you add that without looking at the notes, so we have 0.6532 plus 0.7973. What do you get? Members, what do you get? I want people are active. What do you get? Students, are you there?
Yes, we are there.
Yes, so what do you get when you add?
1.4505.
Yeah, you get 1.4505. That's what you get, isn't it? So what we are going to do is we are going to split up this number here such that we have 10 with the power of the whole number. Are we together? We have 10 with the power of the whole number, then plus 10 with the power of 0.4505. That's what we are going to do. Okay, so we have 10 to the power 1.5, 1.405. That is the log that we have. The log of those two numbers is 1.4505. How did we get this? We found the log of 4.5 as this, and also the log of 6.27 as that. Now, since we are multiplying, we shall have 10 to the power of this first log then times 10 to the power of the second log. Now, if we are multiplying numbers which have the same base, we add the powers. So the power we have is 1.4505. Now, we are going to use the antilog tables or the tables for antilogarithm to find the answer of 4.5 times 6.25. Or we are going to use the tables of antilogarithm to find the antilog of 1.4505. That's what we are going to do. So what we are going to do is we are going to split up this and find the antilog. So we are going to have to find the antilog of 1.4505. So first of all, we split up this and we get the antilog. Members, we get the antilog. We are going to get the antilog of 0.4505, and we shall multiply it by 10 to the power 1. Where did we get this one? This one is the one which is here. So the whole number, it means that we have 10 to the power 1, then times the antilog of this decimal number.
Question.
Yes.
Where is that 0 from 0 point? Where is the 0 from?
This one here.
Yes.
Okay. So when you remove 1 from here, what do you remain with?
0.
So you remain with 0.4505, isn't it?
Yes.
So remove that one. So we have 10 to the power 1, and then we find the antilog of this other number, which is here, which has a decimal point. Later on, we shall see that we can use a table and then our working is okay. Yes, question.
Teacher, I want first go back here behind it. Is why you say that this work changed from log 6 to 7 what and change into indices. I understand that part.
This point here, from here to here.
Yes, the logs change into indices.
Okay, now what you should know is that when you are finding the log of a given number, okay, the log of a given number, that logarithm can be expressed in terms of indices, So if you are, if let's say you are finding the log of this, are we together? If you are finding the log of this, then let me write it for you. If you are finding the log of, let's say, 4.5, so what this can be written in index form. So the log of this is the same as 10 to the power, the answer that you get here. I don't know the answer you get here. Let's say log of x to the power a equals to b, of x to the power a is equal to b. Then you can change this one to index form by saying that x to the power b equals to a, something like that. X to the power b is equal to a. Now what you should know is that in our question, which is here, the base is 10. The base is 10, isn't it? Members, if a log is written without a base, then you should know that the base is 10.
10.
The base is 10. Okay? The base is 10. So if this is our answer that we got as 0.6532, so you can change this. You can change this into power form using this formula here, using this. So if you have log of A of base x is equal to b, then it means that the base to the power to the log is equal to a. The base to the power, the log that you get is equal to that number. So if you have log of 10 of base 10 or 45 equal to 0.6532, then that 10 to the power 0.6532 is equal to 4.5. So that's how you change logs to index form. Logs to index form. That's how you change. You can use a calculator and see 10 to the power of this, and use a calculator and see whether you get 4.5. Use a calculator and see. Don't you get 4.5? I'm asking you, are you using a calculator to check out?
Yes.
Use this using a calculator and see whether you don't get 4.5. So you should know that if the log is written, log of A base x is equal to b, then x to the power the b is equal to that number a. So x to the power to the log is equal to the number what? Number a. So that's why we changed. That's why we changed this. We changed 4.5. We changed this 4.5 because 4.5 can be written as 10 to the power 0.6532. The same way how I've shown you here that 4.5 is the same as 10 to the power 0.6532. How do we get this? We use the logarithm with indices. We use the logarithm with indices. If you use a log table and they tell you find the log of 4.5, the log of 4.5, you just know that if log is written without a base, then the base is 10. The base is 10. So when you go in your tables, all those tables, they are of base 10. They are of base 10. So when you go to your tables, this is the answer you will get as the log of 4.5. The log of 4.5. So to change this back to index form, it means that 10 to the power this, 10 to the power this equals to 45, equals to 45. And I've told you that since we are multiplying 4.5 times 6.27, then where there is 45, I'm putting 10 to the power 0.6532. Are we together? And where there is 6.27, I'm putting 10 to the power, the log of 6.27, which is 0.7973. Letitia, are we together?
Yes, we are together.
Yeah, so that's how we change the logs to the index form, where the base remains the same. If this was the base, it means that also this should be the base when you change it to index form. So if our base was 10 here for the log, then also the base remains the same in the index form. So this is in index form, this is in logarithm format. Are we together?
Yeah. Yes.
Okay, so now after changing these ones to index, we have changed this to index form, we have this, we have changed this to index form, we have this. So afterwards, since we are multiplying the numbers of the same base, we add the powers. We add the what? We add the powers. So that's why we said you have 10 to the power 0.6532, then plus 0.7973. And you get 10 to the power 1.4505. So it means that now, for us to get the answer to this, we have to find the antilog of, so we find the antilog of that power which is here. So the antilog, find the antilog of 1.505. We find that antilog. Okay, find the antilog. Okay, now if we are to split this, do you know what this one means? This one means that we have 10 to the power 1. Are we together? 10 to the power 1 times 10 to the power 0.4505. Because when we have numbers of the same base here, it means that when numbers which have the same base, we just add the powers. If you add this to this, you get 1.4505. Members, are we together? Senior twos, are we together?
Patrick.
Yes.
Yeah.
Yes.
Okay, so it means that if we are to split this in terms of index form, then it means that we have 10 to the power 1 times 10 to the power 0.4505, such that if we are to go back to this, if we want to go back to this, we just add up these powers and we shall go back to that. So it means that this step is almost the same as what? As this one. Because here, if you add 1 plus 0.4505, we shall write it as 10 to the power 1.4505, because we just add 1 plus this, and we shall get that. So here, if you want to find the antilog, we've split this one. So 10 gets this whole number 1 times 10 to the power, the remaining part here. Are we together? Are we together? So our final answer there, I'll go back to our book here. So our final answer now will become, the antilog of this times 10 to the power 1 times 10 to the power 1. This one here, I'd skipped a step, so it is 10 to the power 1 times 10 to the power 0.4505, like that. That's what it means. So we shall get the antilog of this. So do you know how to get the antilog? Can you unmute, members? All of you unmute. Do you know how to get the antilog? Yes? Yes? Do you know how to get the antilog?
No.
You don't know. You don't know. Didn't teacher Watimon teach you how to get to the antilog? He taught us, isn't
Did
it?
not attend.
Some of you did not attend. You attended to chicken. Okay. All right. So let us get to the antilog from these tables. So we go to the antilog. This is for antilog, and we are looking for. Let me first remind you what we are looking for. We are looking for the antilog of 0.4505. 0.4505. Note that one somewhere. Note it somewhere, members. 0.4505. That's the antilog we are looking for. Okay. So let us see how we get that antilog. Now, 0.45. So let us first look for 0.45. 0.45. 0.45. You're looking for 0.45. So it is here. This is 0.45. So I want you to see very well from our notes here. 0.45. We first start with 0.45. 0.45. So we first start with 0.45, and 0.45 is here. Now we go to the next column. The next column here. To go to the next column here, we must look for the third digit here. The third digit is a Z, is a 0. Members, are you there? I don't know why. I don't know why.
Yes,
I don't
we
know why.
are there.
I don't know why you are muting. I don't want people who mute when I'm teaching. I don't want.
Sometimes the background is noisy.
You go to the quiet place, please. For you, why do you study from the middle of the taxi park? Eh? Letitia, why do you study from the middle of the taxi park? Okay.
It's your stubborn sisters.
Okay, those stubborn sisters, make them to be obedient to you. Now, 0.45, so we go to the next digit. Our next digit is 0. Okay, so if that next digit is 0, we also come here and look for 0.45 is here. The next digit is here is 0. So the next digit, this one gives you the column that you have to go to. So this is the column, and the column is of 0. So I go to 0 and I have 2818. 2818. Are we together? I have 2818. Have you seen that? 2818. But what you should know is that with the logarithm, there is a point. With the anti-logarithm, we write to 3 decimal places. So here there is a point, just because in the table it is not shown, but there is a point. So it is 2.818. We write it to 3 decimal places. Are we together? So you should know that all these numbers, they are written to 3 decimal places: 2.891, 2.3.3. So after one digit, there is a point. For anti-log. For anti-what? For anti-log. Are we together?
Anti-log.
For anti-log. Anti-log, so there is a point. Now we have not finished. So this was 0, and 0 was giving us 2.818. Now we go to the third digit. The third digit here is 5. So 5. So 5, what is 5 giving us? So let us see what 5 is giving us. So we go to this other column, this side, and we look for 5. So we look for 5. This is 1, this is 2, this is 3, this is 4, and this is 5. Are we together? Are you seeing my cursor where it is?
Yes.
So this is where 5 is. Now we go to that row where we have 0, where we have 0.45. Which number is there? It is 3. Are you seeing that? Members, the number which is there is what? Is 3. Let me use something here. Okay, do you see this row here? This one. Are you seeing this? We are looking at that, members, isn't it?
Yes.
So the number which is there, we look at 5. So if we look at 5, this is where we have 5 here. This is where we have 5, because in our question we had 4505. So the last digit is 5. Now the number which is there is a 3. Are you seeing that?
A 3.
So yes, since it is a 3, we are going now to add on. So we are going to add on. We are going to add on this. We are going to add on. We are going to add on 0.003, and we add. Are we together? So because it is 3, so 3 we write it to 3 decimal places. Are we together?
Yes.
And then the number we have got is 3, so we write it to 3 decimal places. And then the number that you get, the numbers that you get this side, you write them to 3 decimal places and you add them to the number which you got here. Are we together? By the end of this lesson, you'll have understood what we call antilogs, even if you do not study them. So I thought that you had studied them. Now, if we add here, we get 8 plus 3, we get 11, isn't it? 2, and we have 8, then 0.2. Okay, 0.2. So let us see. Okay, let us see. Okay, so we have 2.821 as our answer there. So we go back here and we say the antlog. Let me first remove this. So it means that the antlog of 1.4505 equals to 2 point. Now this one has given us 2.821, then times 10 to the power 1, like that. So this is the antilog of this. Then afterwards we shall have, if you multiply this one times 10, you get 28.21 as your final answer. I don't know why they have 28.19, but it should be 28.21 as the final answer. So you should be careful when you're reading the log tables. Be careful when you're reading the log tables. Now, this is a rough way, and when you do like this in your exams, you may get a few marks because your work appears to be very disorganized. Are we together? So we are going to see how we can use tables, how we can draw our tables in our working, and we have good presentation. Now, before we proceed to any other thing, I want us to first practice. Are you listening, members? I want us to first practice. Can we get the?
Yes.
Can someone help me? And we get the antilog. The antilog. Let me see. You studied the antilogs. Application of antilog tables to find that logarithm. If you have not studied the antilog. Antilog. Okay. Can we get the antilog of 0.02? Antilog in these 4 minutes which are remaining. So let us go to the table and see. We are getting the antilog of this.
Bluetooth mode.
Okay. We are getting the antilog of this. So first of all, it is 0.3802. So what we are going to do, the first thing, you first go and look for 0.38 in the first column. So this is for the first column. Are we together? You look for 0.38 and it is there. You pause. So you have seen it, it is here. Okay. Then the next thing. So let me use a line here. I don't know whether we have enough time, but you come back. 38 is here. So the next thing, 38 is there. Now the next thing you are going to look for the column of 0. So second gives you the column of 0. This is 0 here. So look for the column of 0, and what is there? It is 2.399. Are we together? Are we together, members?
Yes.
And lastly, this digit gives you the difference. This one. So the third, this digit here you are seeing, this is this digit which is here gives you the difference. This one here will give you the difference. So this you go for, let me call this a number 3. So you look for the difference of 2. So now you look for that 2, and if you are looking for 2, first remove this. So you look for 2 here. We are here, and you look for 2. Column of 2 is here. Now you go up, and we have 1 here. Are you seeing that 1? Members, do you see that 1? Hey, so that 1 you write it. That 1 you write it to 3 decimal places and write it as 0.001. The answer you have got in that column of 2, so it is 1. So that 1 you have got, write it to 3 decimal places. Then afterwards you add this plus this. So you have here 10, here 10, and here 4, and here 2. So we have our answer as 2.4. Answer. So you can see that here the question was the log of 2.4 and is this. So the antilog of this should give you 2.4. So we are going to come back and then we shall do more.